The definition of forward bias. Forward bias the DC voltage required to maintain current flow in a bipolar transistor or diode, or to enhance current flow in a field effect transistor. For example, a silicon diode will conduct current only if its anode is at a positive voltage compared to its cathode. It is then said to be forward biased. This voltage will be approximately 0.6 volt compare reverse bias. Other than that, a diode can only allow current to flow in the forward direction when forward applied voltage is more than barrier potential 0.7 volt or 0.3 volt of the function. If forward applied voltage increase from 0, the diode will start conducting only after this voltage reach just above the barrier potential or forward bias voltage of the junction.
Definition of reverse bias. Reverse bias, the applied DC voltage that prevents or greatly reduces current flow in a diode, transistor, and the other. For example, a negligible current will flow through a diode when its cathode is made more positive than its anode. The diode is then said to be reverse biased. The operation of reverse biasing. Positive terminal of the source is connected to the N-type and the negative terminal of the source is connected to the P-type N of the diode. There will be no current through the diode except reverse saturation current or leakage current. If reverse applied voltage across the diode is continually increased, then after a certain applied voltage the depletion layer will destroy, which will cause a huge reverse current to flow through the diode. If this current is not externally limited and it reaches beyond the safe value, the diode may be permanently destroyed.
The Npn Bipolar Transistor contains a thin p region between two n regions. The PNP Bipolar Transistor contains a thin n region sandwiched between two p regions. The transistor structures. The bipolar junction transistor has three separately doped regions and contains two p-n junctions. Bipolar transistor is a three-terminal device. There is emitter, base, and collector. The basic transistor principle is that the voltage between two terminals controls the current through the third terminal. The current in the transistor is due to the flow of both electrons and holes, hence the name bipolar. There are two types of bipolar junction transistor, that is NPN and PNP. The NPN bipolar transistor contains a thin n region sandwiched between two p regions. The NPN bipolar transistor contains a thin p regions between two n regions.
The function of base, collector, and emitter. The first part, emitter, with the symbol E, to emit or inject electrons into the base. The middle part, base, with the symbol B, to control the current flow through the circuit. The third part, collector, with the symbol C, to collect electrons from base for use in the circuit. Operations NPN. Forward active mode. The base emitter, symbol BE junction, is forward biased and the base collector CB junction is reverse biased. Since the BE junction is forward biased, Electrons from the emitter are injected across the BE junction into the base. Once in the base region, the electrons are quickly accelerated through the base due to the reverse biased CB region. Some electrons, in passing through the base region, recombine with majority carrier holes in the base. This produces the current. Mathematical expressions. Based on KCl, IE equals to IC plus IB. The number of electrons crossing the base region and then directly into the collector region is a constant factor B beta of the number of electrons exiting the base region. IC equals to beta IB. The number of electrons reaching the collector region is directly proportional to the number of electrons injected or crossing the base region. IC equals to alpha IE. Ideally, alpha equals to 1, but in reality, it is between 0.9 and 0.998. Operations PNP. Forward active mode. The emitter base junction is forward biased and the base collector VC junction is reverse biased. Based on KCl, IE equals to IC plus IB.
Okay, now I'm gonna talk about effect of reverse bias on the wave of depletion region. The result is that the depletion layer grows wider due to a lack of electrons and holes and presents a high impedance path, almost an insulator. The result is that a high potential barrier is created, thus preventing current from flowing through the semiconductor material. However, a very small lag current does flow through the junction, which can be measured in microamperes. One final point, if the reverse bias voltage applied to the diode is increased to a sufficiently high enough value, it will cause the PN junction to overheat and fail. This may cause the diode to become shorted and will result in the flow of maximum circuit current. This graph shows that the reverse characteristic curve for a junction diode. The end.